A locomotive is a specialized type of train car which is used to run the whole train. The locomotive is self-propelled, generating energy through the burning of fuel, the use of electricity, magnetic levitation, or other methods. Locomotives can be used to either push or pull train cars. The locomotive is now used all over the world, propelling passengers and freight to various locations. Locomotives are usually extremely powerful as they have to pull or push a series of train cars. They can pull long strings of heavy cars on both flat surfaces and grades. You can think of locomotives as the powerhouse for trains. Locomotives were developed in the 1800s. These initial versions were powered by steam. They enabled the construction of railroads, which rapidly grew into the most dominant method of land transportation. Although the classic image of a locomotive displays its placement at the head of the train, it can also be placed at the back when it is employed for pushing the train. Some railroads also use push-pull operations, in which a locomotive pulls a train in one direction and pushes it in the other. This eliminates the need for time-consuming track switching, as the train can move easily in either direction. When you see an engine running on a railway track without coaches behind it, that is not a train. That is a locomotive traveling on its own. However, when it used to haul the wagons or coaches, the whole unit can be called a train. Though it is common for people to call any system running on rails as a train, it is a vehicle system that consists of a locomotive that provides power and a series of interconnected carriages. A locomotive is a rail transport vehicle that provides the motive power for a train. If a locomotive is capable of carrying a payload, it is usually rather referred to as a multiple unit, motor coach, rail car, or power car. The use of these self-propelled vehicles is increasingly common for passenger trains, but rare for freight trains. Traditionally, locomotives pulled trains from the front. However, push-pull operation has become common, where the train may have a locomotive, or locomotives, at the front, at the rear, or at each end. Most recently railroads have begun adopting DPU, or distributed power. The front may have one or two locomotives followed by a mid-train locomotive that is controlled remotely from the lead unit. Prior to locomotives, the motive force for railways had been generated by various lower technology methods such as human power, horsepower, gravity, or stationary engines that drove cable systems. Few such systems are still in existence today. Locomotives may generate their power from fuel, wood, coal, petroleum, or natural gas, or they may take power from an outside source of electricity. It is common to classify locomotives by their source of energy. The common ones include: a steam locomotive is a locomotive whose primary power source is a steam engine. The most common form of steam locomotive also contains a boiler to generate the steam used by the engine. The water in the boiler is heated by burning combustible material, usually coal, wood, or oil, to produce steam. The steam moves reciprocating pistons which are connected to the locomotive's main wheels, known as the driving wheels. Both fuel and water supplies are carried with the locomotive, either on the locomotive itself, in bunkers and tanks. This arrangement is known as a tank locomotive, or pulled behind the locomotive, in tenders. This arrangement is known as a tender locomotive. The first full-scale working railway steam locomotive was built by Richard Trevithick in 1802. It was constructed for the Coalbrookdale Iron Works in Shropshire in England, though no record of it working there has survived. 3 On February 21, 1804, the first recorded steam-hauled railway journey took place as another of Trevithick's locomotives hauled a train from the Penydarren Iron Works, in Merthyr to Abercynon in South Wales. 4-5 Accompanied by Andrew Vivian, it ran with mixed success. 6 The design incorporated a number of important innovations, including the use of high-pressure steam which reduced the weight of the engine and increased its efficiency. In 1812, Matthew Murray's twin-cylinder rack locomotive Salamanca first ran on the edge-railed rack and pinion Middleton Railway 7. This is generally regarded as the first commercially successful locomotive. 8-9 Another well-known early locomotive was Puffing Billy, built 1813-14 by engineer William Hedley for the Willem Colliery near Newcastle upon Tyne. This locomotive is the oldest preserved, and is on static display in the Science Museum, London. George Stephenson built locomotion number 1 for the Stockton and Darlington Railway in the northeast of England, which was the first public steam railway in the world. In 1829, his son Robert built the Rocket in Newcastle upon Tyne. Rocket was entered into, and won, the Rainhill trials. This success led to the company emerging as the preeminent early builder of steam locomotives used on railways in the UK, US and much of Europe. 10. The Liverpool and Manchester Railway, built by Stephenson, opened a year later, making exclusive use of steam power for passenger and goods trains. The steam locomotive remained by far the most common type of locomotive until after World War II. 11. Steam locomotives are less efficient than modern diesel and electric locomotives, and a significantly larger workforce is required to operate and service them. 12. British Rail figures showed that the cost of crewing and fueling a steam locomotive was about 2.5 times larger than the cost of supporting an equivalent diesel locomotive, and the daily mileage they could run was lower. Citation needed. Between about 1950 and 1970, the majority of steam locomotives were retired from commercial service and replaced with electric and diesel, electric locomotives. 1314 While North America transitioned from steam during the 1950s, and continental Europe by the 1970s, in other parts of the world, the transition happened later. Steam was a familiar technology that used widely available fuels and in low-wage economies did not suffer as wide a cost disparity. It continued to be used in many countries until the end of the 20th century. By the end of the 20th century, almost the only steam power remaining in regular use around the world was on heritage railways. Internal combustion locomotives use an internal combustion engine, connected to the driving wheels by a transmission. They typically keep the engine running at a near constant speed whether the locomotive is stationary or moving. Internal combustion locomotives are categorized by their fuel type and subcategorized by their transmission type. The first internal combustion rail vehicle was a kerosene-powered Draisine built by Gottlieb Daimler in 1887-15, but this was not technically a locomotive as it carried a payload. The earliest gasoline locomotive in the western United States was built by the Best Manufacturing Company in 1891 for San Jose and Alum Rock Railroad. It was only a limited success and was returned to Best in 1892. 16. The first commercially successful petrol locomotive in the United Kingdom was a petrol, mechanical locomotive built by the Maudslay Motor Company in 1902, for the Deptford cattle market in London. It was an 80 HP locomotive using a 3-cylinder vertical petrol engine, with a 2-speed mechanical gearbox. Diesel locomotives are powered by diesel engines. In the early days of diesel propulsion development, various transmission systems were employed with varying degrees of success, with electric transmission proving to be the most popular. In 1914, Hermann Lemp, a General Electric electrical engineer, developed and patented a reliable direct current electrical control system. Subsequent improvements were also patented by Lemp. Lemp's design used a single lever to control both engine and generator in a coordinated fashion, and was the prototype for all diesel, electric locomotive control. In 1917-18, GE produced 3 experimental diesel, electric locomotives using Lemp's control design. In 1924, a diesel, electric locomotive started operations. It had been designed by a team led by Yuri Lomonosov and built 1923-1924 by Maskinen Fabrik Esslingen in Germany. It had 5 driving axles, 1 E1. After several test rides, it hauled trains for almost 3 decades from 1925 to 1954. An electric locomotive is a locomotive powered only by electricity. Electricity is supplied to moving trains with a, nearly, continuous conductor running along the track that usually takes one of 3 forms: an overhead line, suspended from poles or towers along the track or from structure or tunnel ceilings, a third rail mounted at track level, or an onboard battery. Both overhead wire and third rail systems usually use the running rails as the return conductor, but some systems use a separate fourth rail for this purpose. The type of electrical power used is either direct current, DC, or alternating current, AC. Various collection methods exist: a trolley pole, which is a long flexible pole that engages the line with a wheel or shoe; a bow collector, which is a frame that holds a long collecting rod against the wire; a pantograph, which is a hinged frame that holds the collecting shoes against the wire in a fixed geometry; or a contact shoe, which is a shoe in contact with the third rail. Of the three, the pantograph method is best suited for high-speed operation. Electric locomotives almost universally use axle-hung traction motors, with one motor for each powered axle. In this arrangement, one side of the motor housing is supported by plain bearings riding on a ground and polished journal that is integral to the axle. The other side of the housing has a tongue-shaped protuberance that engages a matching slot in the truck, bogie, bolster, its purpose being to act as a torque reaction device, as well as a support. Power transfer from motor to axle is effected by spur gearing, in which a pinion on the motor shaft engages a bull gear on the axle. Both gears are enclosed in a liquid-tight housing containing lubricating oil. The type of service in which the locomotive is used dictates the gear ratio employed. Numerically high ratios are commonly found on freight units, whereas numerically low ratios are typical of passenger engines. Electricity is typically generated in large and relatively efficient generating stations, transmitted to the railway network and distributed to the trains. Some electric railways have their own dedicated generating stations and transmission lines, but most purchase power from an electric utility. The railway usually provides its own distribution lines, switches, and transformers. Electric locomotives usually cost 20% less than diesel locomotives. Their maintenance costs are 25 to 35% lower, and cost up to 50% less to run. The earliest systems were DC systems. The first electric passenger train was presented by Werner von Siemens at Berlin in 1879. The locomotive was driven by a 2.2 kilowatts series wound motor, and the train, consisting of the locomotive and 3 cars, reached a speed of 13 kilometers per hour. During 4 months, the train carried 90,000 passengers on a 300-meter-long, 984 feet, circular track. The electricity, 150 VDC, was supplied through a third insulated rail between the tracks. A contact roller was used to collect the electricity. The world's first electric tram line opened in Lichterfelde near Berlin, Germany, in 1881. It was built by Werner von Siemens, see Gross-Lichterfelde Tramway and Berlin Strassenbahn. The Volks Electric Railway opened in 1883 in Brighton, and is the oldest surviving electric railway. Also in 1883, Mödling and Hinterbrühl tram opened near Vienna in Austria. It was the first in the world in regular service powered from an overhead line. 5 years later, in the U.S. electric trolleys were pioneered in 1888 on the Richmond Union Passenger Railway, using equipment designed by Frank J. Sprague. 21. The first electrically worked underground line was the City and South London Railway, prompted by a clause in its Enabling Act prohibiting use of steam power. It opened in 1890, using electric locomotives built by Mather and Platt. Electricity quickly became the power supply of choice for subways, abetted by the Sprague's invention of multiple unit train control in 1897. The first use of electrification on a main line was on a 4-mile stretch of the Baltimore Belt Line of the Baltimore and Ohio, B&O, in 1895, connecting the main portion of the B&O to the new line to New York through a series of tunnels around the edges of Baltimore's downtown. 3 BO plus BO units were initially used. At the south end of the electrified section, they coupled onto the locomotive and train and pulled it through the tunnels. DC was used on earlier systems. These systems were gradually replaced by AC. Today, almost all mainline railways use AC systems. DC systems are confined mostly to urban transit such as metro systems, light rail, and trams, where power requirement is less. The first practical AC electric locomotive was designed by Charles Brown, then working for Ehrlichen, Zurich. In 1891, Brown had demonstrated long-distance power transmission, using three-phase AC, between a hydroelectric plant at Laufen am Neckar and Frankfurt am Main West, a distance of 280 kilometers. Using experience he had gained while working for Gene Heilmann on steam, electric locomotive designs, Brown observed that three-phase motors had a higher power-to-weight ratio than DC motors and, because of the absence of a commutator, were simpler to manufacture and maintain. However, they were much larger than the DC motors of the time and could not be mounted in underfloor bogies, they could only be carried within locomotive bodies. In 1894, Hungarian engineer Kalman Kandó developed a new type three-phase asynchronous electric drive motors and generators for electric locomotives. Kandó's early 1894 designs were first applied in a short three-phase AC tramway in Evian-les-Bains, France, which was constructed between 1896 and 1898. 26, 27, 28, 29, 30 In 1831 Kandó invented and developed the rotary phase converter, enabling electric locomotives to use three-phase motors whilst supplied via a single overhead wire, carrying the simple industrial frequency, 50 Hz, single-phase AC of the high-voltage national networks. In 1896, Ehrlichen installed the first commercial example of the system on the Lugano tramway. Each 30-ton locomotive had two 110 kilowatts, 150 HP, motors run by three-phase 750 V 40 Hz fed from double overhead lines. Three-phase motors run at constant speed and provide regenerative braking, and are well suited to steeply graded routes, and the first mainline three-phase locomotives were supplied by Brown, by then in partnership with Walter Boveri, in 1899 on the 40 km Bergdorf-Thun line, Switzerland. The first implementation of industrial frequency single-phase AC supply for locomotives came from Ehrlichen in 1901, using the designs of Hans Ben Eschenberg and Emil Huber-Stockar. Installation on the Seebach-Wettingen line of the Swiss Federal Railways was completed in 1904. The 15 kV, 50 Hz 345 kilowatts, 460 HP, 48-ton locomotives used transformers and rotary converters to power DC traction motors. Italian railways were the first in the world to introduce electric traction for the entire length of a main line rather than just a short stretch. The 106 km Valtellina line was opened on September 4, 1902, designed by Kandó and a team from the Gans works. The electrical system was three-phase at 3 kV 15 Hz. The voltage was significantly higher than used earlier and it required new designs for electric motors and switching devices. The three-phase two-wire system was used on several railways in northern Italy and became known as the Italian system. Kandó was invited in 1905 to undertake the management of Società Italiana Westinghouse and led the development of several Italian electric locomotives. A battery, electric locomotive, or battery locomotive, is an electric locomotive powered by onboard batteries, a kind of battery electric vehicle. Such locomotives are used where a conventional diesel or electric locomotive would be unsuitable. An example is maintenance trains on electrified lines when the electricity supply is turned off. Another use is in industrial facilities where a combustion-powered locomotive, i.e., steam or diesel-powered, could cause a safety issue due to the risks of fire, explosion, or fumes in a confined space. Battery locomotives are preferred for mines where gas could be ignited by trolley-powered units arcing at the collection shoes, or where electrical resistance could develop in the supply or return circuits, especially at rail joints, and allow dangerous current leakage into the ground. Battery locomotives in over-the-road service can recharge while absorbing dynamic braking energy. The first known electric locomotive was built in 1837 by chemist Robert Davidson of Aberdeen, and it was powered by galvanic cells, batteries. Davidson later built a larger locomotive named Galvani, exhibited at the Royal Scottish Society of Arts exhibition in 1841. The 7-ton vehicle had two direct drive reluctance motors, with fixed electromagnets acting on iron bars attached to a wooden cylinder on each axle, and simple commutators. It hauled a load of 6 tons at 4 miles per hour, 6 kilometers per hour, for a distance of 1.5 miles, 2.4 kilometers. It was tested on the Edinburgh and Glasgow Railway in September of the following year, but the limited power from batteries prevented its general use. Another example was at the Kennecott Copper Mine, Locomotives, Alaska, where in 1917 the underground haulage ways were widened to enable working by 2 battery locomotives of 4 plus 1 2 tons. 42 In 1928, Kennecott Copper ordered 4 700 series electric locomotives with onboard batteries. These locomotives weighed 85 tons and operated on 750-volt overhead trolley wire with considerable further range whilst running on batteries. 43 The locomotives provided several decades of service using nickel-iron battery, Edison, technology. The batteries were replaced with lead-acid batteries, and the locomotives were retired shortly afterward. All 4 locomotives were donated to museums, but one was scrapped. The others can be seen at the Boone and Scenic Valley Railroad, Iowa, and at the Western Railway Museum in Rio Vista, California. The Toronto Transit Commission previously operated a battery electric locomotive built by Nippon Sharyo in 1968 and retired in 2009. 44. London Underground regularly operates battery electric locomotives for general maintenance work. In the early 1950s, Lyle Borst of the University of Utah was given funding by various U.S. railroad line and manufacturers to study the feasibility of an electric drive locomotive, in which an onboard atomic reactor produced the steam to generate the electricity. At that time, atomic power was not fully understood. Borst believed the major stumbling block was the price of uranium. With the Borst atomic locomotive, the center section would have a 200-ton reactor chamber and steel walls 5 feet thick to prevent releases of radioactivity in case of accidents. He estimated a cost to manufacture atomic locomotives with 7,000 HP engines at approximately $1,200,000 each. Consequently, trains with onboard nuclear generators were generally deemed unfeasible due to prohibitive costs. In 2002, the first 3.6-ton, 17 kilowatts hydrogen-fuel cell powered mining locomotive was demonstrated in Val d'Or, Quebec. In 2007 the educational mini hydrail in Kaohsiung, Taiwan went into service. The Rail Power GG20B finally is another example of a fuel cell electric locomotive. There are many different types of hybrid or dual-mode locomotives using 2 or more types of motive power. The most common hybrids are electrodiesel locomotives powered either from an electricity supply or else by an onboard diesel engine. These are used to provide continuous journeys along routes that are only partly electrified. Examples include the EMD FL9 and Bombardier Alp 45 DP. There are 3 main uses of locomotives in rail transport operations: for hauling passenger trains, freight trains, and for switching, UK English, shunting. Freight locomotives are normally designed to deliver high starting tractive effort and high sustained power. This allows them to start and move long, heavy trains, but usually comes at the cost of relatively low maximum speeds. Passenger locomotives usually develop lower starting tractive effort but are able to operate at the high speeds required to maintain passenger schedules. Mixed traffic locomotives, US English, general purpose or road switcher locomotives, meant for both passenger and freight trains do not develop as much starting tractive effort as a freight locomotive but are able to haul heavier trains than a passenger locomotive. Most steam locomotives have reciprocating engines, with pistons coupled to the driving wheels by means of connecting rods, with no intervening gearbox. This means the combination of starting tractive effort and maximum speed is greatly influenced by the diameter of the driving wheels. Steam locomotives intended for freight service generally have smaller diameter driving wheels than passenger locomotives. In diesel-electric and electric locomotives, the control system between the traction motors and axles adapts the power output to the rails for freight or passenger service. Passenger locomotives may include other features, such as head-end power, also referred to as hotel power or electric train supply, or a steam generator. Some locomotives are designed specifically to work steep-grade railways, and feature extensive additional braking mechanisms and sometimes rack and pinion. Steam locomotives built for steep rack and pinion railways frequently have the boiler tilted relative to the locomotive frame, so that the boiler remains roughly level on steep grades. Locomotives are also used on some high-speed trains. Some of them are operated in push-pull formation with trailer control cars at another end of a train, which often have a cabin with the same design as a cabin of locomotive. Examples of such trains with conventional locomotives are Railjet and Intercity 225. Also many high-speed trains, including all TGV, many Talgo, 250/350/Avril/XXI, some Korea Train Express, ICE-1/ICE-2 and Intercity 125, use dedicated power cars, which do not have places for passengers and technically are special single-ended locomotives. The difference from conventional locomotives is that these power cars are an integral part of a train and are not adapted for operation with any other types of passenger coaches. On the other hand, many high-speed trains such as the Shinkansen network never use locomotives. Instead of locomotive-like power cars, they use electric multiple units, EMUs, or diesel multiple units, DMUs, passenger cars that also have traction motors and power equipment. Using dedicated locomotive-like power cars allows for a high ride quality and less electrical equipment, but EMUs have less axle weight, which reduces maintenance costs, and EMUs also have higher acceleration and higher seating capacity. Also some trains, including TGV PSE, TGV TMST, and TGV V150, use both non-passenger power cars and additional passenger motor cars. Operational role. Locomotives occasionally work in a specific role, such as train engine is the technical name for a locomotive attached to the front of a railway train to haul that train. Alternatively, where facilities exist for push-pull operation, the train engine might be attached to the rear of the train. Pilot engine, a locomotive attached in front of the train engine, to enable double heading. Banking engine, a locomotive temporarily assisting a train from the rear, due to a difficult start or a sharp incline gradient. Light engine, a locomotive operating without a train behind it, for relocation or operational reasons. Occasionally, a light engine is referred to as a train in and of itself. Station pilot, a locomotive used to shunt passenger trains at a railway station. The wheel arrangement of a locomotive describes how many wheels it has. Common methods include the AAR wheel arrangement, Uick classification, and White notation systems. In the second half of the 20th century, remote control locomotives started to enter service in switching operations, being remotely controlled by an operator outside of the locomotive cab. The main benefit is one operator can control the loading of grain, coal, gravel, etc. into the cars. In addition, the same operator can move the train as needed. Thus, the locomotive is loaded or unloaded in about a third of the time. Thank you for watching this video.